Hi everybody, and welcome to this week's Matrix Live. Not with Amandine this week, but with Eric instead, as we have got to the end of a fairly never-ending week, and as is now increasingly traditional, crack to open the beers in order to wind down and tell you all about the amazing things that have been happening. Amandine's on holiday today, and so Eric is very willingly been strong-armed into substituting for her, as well as it being particularly relevant, because lots of the stuff to talk about this week are ones which are in your domain, right?
Yes.
Shall we start off on the Synapse side of things? Synapse 33.
Yeah, it's out and got some really surprising performance improvements in the sync stuff. We fixed something that was annoying me, that just we were doing lots of transactions. We fixed that. And
that was the linearized read receipt transactions being alarmingly high.
It was like 40 hertz of transactions when we only have like 0.5 hertz of receipts going through the system at a time. So that's been annoying me for a while, and I finally figured out how or why that was happening, fixed it, and suddenly things went faster. Mm-hmm. So that was slightly unintentional, but...
This is one of the first ever Synapse releases where I have random people DMing me who I've never heard from before, congratulating us on how much faster Synapse has got. So it really isn't just our graphs and other people out there who had relatively high traffic servers were really seeing the pain there. So it's nice that that's back to where it should be. A bit unfortunate that it was a bug that needed to be fixed rather than a sort of fundamental thing, but still heading in the right direction. What else in Synapse? So if you're not on 33, please upgrade, because it is worth it. And otherwise, Rich has been doing a lot of work on room versioning, ready to get everybody upgraded to the new state res algorithm, which we're about to talk all about. And also, I've been doing some work on lazy loading. Did a random hackathon last night to stack up. I think we're now 5 PRs nested deep, unfortunately, on lazy loading stuff for Synapse. But it basically implements the MSC that we had for lazy loading in all of its glory, with the exception of the room summary API. But you can now do things like request the membership of a room as of a given as of a given event, which is pretty important, and a whole bunch of other things. It's even got side tests, and it looks like it might even work. I've also been doing I don't know why I've become a Synapse developer for a few days this week. I'm sorry, apologies to the Synapse team. But also went and implemented a whole bunch of stuff for stats in Synapse. This takes the form of 2 new tables, room stats and user stats, which goes and checks a time series of useful metrics about your users and your rooms, such that we might actually get an admin API in the end that is useful in terms of tracking where your resources are going. So this could be useful for people on constrained home servers, specifically the disroot.org guys. Made me think that we really should have this, because they use a lot of disk space and they're very unhappy about it. And we wanted to be able to see, where is your disk space going. Also good for people who want to do quotas and say, if you don't want to be providing free infinite media storage to the internet and say, hey, a given user is only allowed 1 gigabyte of uploads or something, then it goes and provides that too. That isn't PR'd yet, but it will be soon. Do you want to take that one, Eric?
Well, apparently I've just finished a big bit of work, so I might have some time now.
Well volunteered. On the Riot side, on Riot Web, we've also had a whole bunch of stuff happening. We've got new Jitsi upgraded for the first time ever, and it's just day and night. We've been trying to use Jitsi internally to talk to Bruno, who's one of the new Riot Web developers based in Berlin, and it was unusable until we upgraded it today, and then it was absolutely perfect. So literally, if you hit Jitsi right now in Riot Web, you might get a much better experience, at least as good as Hangouts, than the rather shonky thing that we had before. The Slate rich text editor got merged to Develop, so if you're not on Develop and you haven't experienced the weirdnesses and wonders of a slightly better, in almost always, rich text editor, then you should go and check it out. Lazy loading work on the client side is also progressing. Bruno's been doing that, and there's a branch which uses all the new lazy loading APIs, and it speeds everything up by a factor of about 5. At least in initial sync. and it also uses a lot less RAM because it stores the members separately from the rest of the sync. What we haven't done is to ship Riot 16 because it got blocked behind making sure that Slate actually worked. Michael, tech guy, has been hacking away at that though, and it's almost done, coming out soon. Finally, on Riot Mobile side of things, there's been ongoing work on performance and stability and lazy loading critically on iOS, which I think is also almost done. So spec. Let's talk about spec. Should we do the three boring, not boring, but the business as usual things, and then we can talk about state res. So tell us about the tooling stuff, Eric.
We've been trying to figure out, there's been a lot of new interest in making proposals and how exactly we do all the tooling around that, and the actual process of getting something into the spec and talking about the spec and discussing it. So there's been, I think, all week we've been talking about it and discussing the various options.
I think it started at the end of June, actually, when Noah particularly said, hey, why don't we use Discourse? And there was, at that point, an internal discussion about whether to use Discourse or GitHub or what, and it got completely 50-50 split down the middle. And then Adam, who's probably most well known for the Python SDK maintainer, came up with a separate MSC proposal for using Discourse, which reignited the whole thing again. But I think we might actually have consensus, or at least sufficient agreement now, to just go and use GitHub, and both with PRs and Markdown, a bit like we used to, but hopefully in a slightly more structured way, to track the proposals, and let's see how it goes.
Yeah.
So we need to probably write that up on the various MSCs in question, but at least in the matrix room that is backing them, there seemed to be pretty good agreement, and it is naughtily violating the MSC process in terms of the fact that everybody agreed in the room, so we said, hey, let's just go and do it, rather than waiting a week or whatever for people to get agreement, but at least we've made progress on it.
Which MSC proposal do you use to, do the MSC proposal?
Yeah, it's a little bit of a bootstrapping problem. But proverbial chicken and egg. Travis has been blitzing for all the server-to-server stuff. Swagger are flying it up and producing the increasingly alarming PR backlog. And I think that's also moved on to adding bits as well as refactoring. Also, Hubert's been doing, or Uharag has been doing the identity server swaggering stuff too. And I'm sure I think we're up to like 28 open PRs at the moment on the matrix.repository. repository. So we have our work cut out for us to review and get them back together. But the reason we're all here, and the exciting thing, is to talk about state resolution reloaded. God, at least we're not calling it state resolution revolutions, because that would be even worse. It's here. We've just announced it. I just announced it on Hashmatrix Spec. Is this big, 18 page document that Eric's been working on for the last month or so, and tell us all about it.
Yeah, so as some of you may know, we have, state resolution has been something that hasn't been working particularly well for a while now. So it's what really backs a lot of the matrix room. It's the core almost of how matrix rooms work in terms of things like membership and topic and name. And really, it's also used for things like kicking people and banning people, so it's incredibly important for moderation.
So just so that people who aren't familiar with the innermost secrets of matrix understand, the state is the key values for a room. So it's all that good stuff that you mentioned, and the resolution bit of it is what you do if you've got two different servers with different view of the rooms and you want to somehow merge them back together in a consistent state, which happens very surprisingly frequently.
Yeah.
Like if you're on jki.re, I'm on matrix.org, and we're busily talking over each other, every time we talk over one another, there's a little fork in the graph, and there's a race, and then they get merged again. And if that was an interesting thing, rather than a message like a join or a kick or a ban, then you have a completely inconsistent state. How do you resolve it together?
Yeah, the fun ones are when you on one side of the fork you have people talking, and then the other side you have people banning those people. And how do you actually what on earth is that meant to look like? The current one, it works technically from a very sort of technically correct point of view, but there are some big issues like it's quite easy to maliciously fork the room, and that allows you to evade bans and kicks if you're particularly cunning, which is bad. So I've been trying to come up with a new algorithm that tries to, build on top of the existing one and is slightly better. This has caused my brain to melt out of my ears a bit, but we now have at least a document with a proposal and hopefully enough background story and enough sort of various ideas that is a starting point for us to come up with the right thing.
And it's worth noting that we're not saying this is finished. This is not the one true state resolution algorithm to save us all. It's an iteration on what we had before, but one that hopefully addresses all of the known issues in the current one, I think it's fair to say.
Yeah.
A couple of gotchas still on this one, but they are a lot more edge casey and critically not maliciously exploitable, unlike the limitations of the somewhat more naive one that we started with.
Basically, I think we came up with a bunch of ideas as we brainstormed the other week, and it's just an amalgamation of all those ideas. So it'd be really interesting to hear if people from the community have, some other really neat ideas that we can incorporate into it.
There've been a lot of discussion about alternative ways of doing this over the last year or so, as various people have been frustrated and bitten by the state reset problem. And in fact, most people will probably be familiar with this in the form of state resets, where you find yourself magically transported back into a room without rejoining it, or you find the topic of the room is suddenly from 3 years ago for no good reason. And all of this is due to surprising results, shall we say, in how the current algorithm works. And hopefully those are almost all mitigated by the new one.
Yeah.
So how does it work, Eric?
Oh, good Lord. So really, there's two big problems with the old one, and that's moderation, evasion, so malicious people sort of trying to do malicious things, and there's the state resets. So like one of the big problems with state resets was that if you have a really large fork and on one side you have people doing a lot of leaves and joins and on power level changes, on the other side you have a bunch of other stuff. When you come to merge them together, the algorithm just gets completely confused because you have all these random joins and kicks and stuff that doesn't make any sort of sense by themselves. And so it just goes, no, all of this is wrong, and it rolls back the state to a really prehistoric point, which is why it gets so, state resets happen. So what the new algorithm does is actually look at what's called the auth chain. So every event has some pointers to things like the power levels and joins and join rules that say, I'm allowed to do this, I'm allowed to join, I'm allowed to send a message because I have there's this power level that lets me do this, there's the join rules are open, or I have this invite or whatever. And so you have this really kind of nice chain of authorization that goes back. And the new algorithm actually pays attention to that. And so when you have these big forks, it actually looks at the auth chain and tries to merge it together more in a more, what's the word? A sensible manner. More reliable.
Safe is probably the best word actually for this, because previously where we were just ignoring the auth chain, it's quite an interesting algorithm because you basically model the state on either side of the fork that you're trying to resolve as a big blob of state. We don't look at the DAG structure of those state events, because we might not have it all. And this is the thing that I personally repeatedly fail to wrap my head around. But it's really quite a nice kind of constraint on the problem that you do not want your little server to have every single state event ever, or every state transition, or even worse, every event ever for a room. Because you might have only just joined it, might be a really large room, might be a really old room, or whatever. You might be on a little Raspberry Pi or a phone or something. So by going and just saying, hey, we have a whole set of events on one side and a whole set of events on the other side, how can we order these sensibly and mix them together? was basically what the old one was doing, but without considering this auth data. Now, with the auth data in it, we hopefully get the best of both worlds, that there is a sort of hierarchy and a kind of authority to these events, so that things like bans can't be overridden, and well, you've basically gone and split the auth events right into ones which give sort of power and ones which revoke power of some flavour. Power is probably the wrong word.
Authorized
things and deauthorized things.
So I mean, on the one hand, you have the auth chain, which allows you to actually have some ordering to this and pull in sort of intermediate events that you wouldn't have otherwise seen. So like a classic one which happened with hash off topic was you'd have a sequence of power level changes going along. So like Alice gives Bob power, Bob gives Charlie power, and blah 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 blah. At the end of it, the old algorithm would only see Bob trying to give Charlie power and never see that Alice was trying to give Bob power, and so it just goes nope, devolves back to the previous one. So that's what the sort of auth chain allows you to do, is pull in all these intermediary things and actually consider that authorization chain. Separately to that, you have this idea of splitting up the state events into really important things like bans and kicks and changing of join rules and changing of power levels. All of the sort of events which change the rules almost. So that because I mean those are the really really important ones from a moderation point of view. You don't want those to be avoided.
And we're calling those power events.
We're calling those power events. It's a terrible, terrible, terrible name. I always get confused with power level events, but never mind. Those are sort of the ones that we consider really, really important, and those are the ones we consider first. So if you have this fork and you have Alice banning Bob, we don't want Bob to just be able to fork from before and start changing the topics and start changing the names and sending messages and the rest of it. So when those fork merges back again, we'll first look at the power level events, which is Alice has banned Bob, and then we go, well, Bob's banned, therefore we're going to disregard everything he's done subsequently. So that kind of makes it a lot easier to make sure that you can't just maliciously avoid it, because you're doing the bans first, and that's actually done via who has the greatest power level. So if you have Bob has power level and Alice has power level, it's whoever has the largest power level wins. So it's really nice that if you have a moderator that goes or goes and tries to fuck things up, then Alice wins.
I'm going to have to bleep this out now.
Oh no! Yes, but after the watershed, right?
So, and I guess that is effectively the mainline ordering part of it.
So that's that's the reverse topological power ordering.
Okay, so I mean, practically speaking, we've got 5 steps here. That you take your big blob of state events on one side, big blob of state events on the other side. First of all, you order them by the reverse topological power ordering.
Yeah.
Which
catchy names, right?
Yeah. And so that's looking at the power events.
So that's the looks at the power events and looks at their auth chain.
Yeah, so it's the topology of the auth DAG for those power events, and you do them most powerful to least powerful, and then you basically play those back one by one as if you were receiving them for the first time, doing the auth checks on those one by one, and you put it on top of the unconflicted state, i.e. the bits of the state which are in common to your 2 separate blobs of state. And then you calculate a new ordering of the remaining stuff, which is called the mainline ordering. Tell us about the mainline ordering.
Oh, the mainline. So you first take out all the power events, so things like kicks and bans, and then you do this algorithm and do all the auth checks first, and then you take your remaining events, which are the slightly more boring, joins, leaves, topics, things, names, and we want to. The thing with that is we want to be able to order them basically by some sort of time. We don't have none of those appear in the auth chain, so you don't get any ordering from the auth chain. And if you're not careful, if you just pick an arbitrary ordering, what you'll often get is the oldest one might win or the newest one might win, and it's not great at all.
And we can't do it by the shape of the DAG because we might not have the state of the DAG.
All we know is we have topic 2 and topic 4, or we don't even know there's 2 and 4. How do you choose? So one of the things that we could use is the origin server TS, which is the timestamp that's in the event that says when the remote server sent it, which is great for servers that you trust or servers that have their clock set correctly and things like that. But there are some malicious servers out there, or people that like to play around with their clocks. And if you send a topic event from the year 3000, then you don't want that to be stuck at the top of your room forevermore. So it's kind of like a nice thing to use, but you can't trust it. So what we've come up with instead is this idea of a mainline, where you take the power level events that you've resolved in the first step with the reverse topological power order.
And this is the bit which I always get confused about. It's not the power events, it's the power level
events. Yeah.
So it's literally the series of people who've changed the power level in the room over time and the shape of the DAG that produces.
Yeah. So every time someone changes the power levels, you just get almost like a new epoch of the room.
Yeah.
And so once you've resolved the power level events from step 1, then you have a single power level event, and you can track back through their auth events this long list of power levels. You get a nice main line of power levels. And then what you do with the remaining events that you haven't resolved yet is you figure out if you trace back, so that every single one of those events points to a power level event in their auth events, and you keep tracing those back until they hit this main line. And then you use where on that main line they sort of merge in
order to
order them. So you end up with kind of like, topics 2 was from the previous epoch, but topic 4 is from this new epoch.
So practically speaking, do you end up with literally a linear sequence that goes power, event, power, event? Okay.
Yeah.
So you're literally linearizing the boring state changes, splitting them into epochs, delimited by power levels, and possibly other events in future.
Yeah.
That's a little bit up in the air right now. But certainly power levels, at least with the current structure of rooms.
Yeah.
And then you play those all out on top of the state that you got in the first phase. And then finally, you blat the unconflicted state over the top.
Yeah.
It's hopefully not PagerDuty. That is PagerDuty. Let's hope that... Oh yeah, we've got people who can go and get matrix.org back up.
Be fine.
Yay. So yes, you then go and blat the unconflicted state over the top.
Yep.
In order to smooth over.
It's annoying. Ideally, we wouldn't have to do this, but in practice, actually, from the nitty-gritties of how it actually works, in practice, you have to splat the unconflicted stuff on top to make sure that the idea is that all the unconflicted events are in the final state resolution.
Yeah.
But that doesn't always happen in the current thing. So we just do that as a final sanity check. Yeah.
So there you have it. Simple, right?
Yeah.
I mean, the good news, and something that made me a lot happier about this, is that you got TestJig for playing with it, which is now on the matrix-org repository somewhere.
Yes.
Called Test State
Ideas. Test State Ideas.
Right, Test State Ideas. And it's a little bit of Python 3 that Eric's put together.
Yep.
When you feed in YAML that describes the shape of a hypothetical DAG, and it runs different algorithms, and we've got a bunch of test cases and see whether it works. And basically, how many? I think there are about 6 tests there now? Or
yeah, something like that.
But hopefully 6 of the kind of classic bug scenarios that we had in the previous algorithm, and we can just play the new one over it and see that it works. Yeah. There's a little bit of an empirical element to this, and some people might be saying, oh my god, this isn't as formal a proof as we might hope. It's worth noting that merge resolution full stop is a bit of a fuzzy field. If you look at how patch and diff work, there are many, many different ways to just do merge resolution on a text document, all with slightly different trade-offs and quality of an end result. I think it's basically the same here.
Yeah.
And we can reason about what we have relatively well here, but I think we're definitely going to have to iterate on it a bit more.
Yeah.
So what's next?
Well, I was going to quickly say, like, with the new room versioning algorithm, we don't need to get this 100% right this time. If it turns out there's some annoying edge cases which we can fix later, with this room version, and that makes me a lot happier than before than having to get it right first time.
Yeah. And critically, it fixes the bugs which we know about today.
Yeah.
Which is always going to be an improvement from where it is. It does have the disadvantage that it's slower, right?
Yes, it is slower. So I had a test case that I was using to do performance, and the old algorithm ran in 20 milliseconds, and the new algorithm runs in about 250 milliseconds, which is a little bit slower. And yeah, unfortunately, state resolution is somewhat on the hot path of Synapse, and it's why it's so slow at the moment anyway.
So it's a potential disaster in terms of being 10 times slower. But the good news is that we think it still works with the incremental algorithm.
Yeah, so with the algorithm that we propose today, it makes it a lot easier to reason about how to do this in a very sort of delta incremental way. So if you've done this resolution once, you can reuse that work. And that should be really quick. Because in some ways, a lot of the slowness in certainly in the Python version of this is simply just the sheer amount or sheer size of the state. So taking that out of the database and then doing dips.
Honestly, I think it's fine if the algorithm is computationally more chunky if it's just not operating on the same level of data. I mean, it should be fine. When's it going to land?
Oh, good Lord. So we have something that I can plug in today, I think.
Oh, really?
It just means...
In Python 3 or Rust?
No, in Python 3, I resist the urge of writing this in Rust. But yeah, so
we're going to have a comedy dependency that we have to wait for Synapse to port over to Python 3, which we totally forgot to mention. That the Python 3 port is coming along really well. Possibly aiming for getting a synchrotron on it next week, or possibly early next week.
Yeah, I think Hall Cowell's planning to put her server on first, and then she did notice that the PsyTest or the Federation test broke, so she was like, maybe I shouldn't do that just before going away for the weekend. Just breaking your Federation. So that's really exciting. I mean, I think it should work in Python too. I was using a library that was Python 3 only or something. I can't remember why.
Cool, so you can just dump it in there.
Yeah, it should.
And I was admiring the unit tests in Synapse for state res. It turns out there are some.
Oh yeah, there are. Yeah, they're quite.
We even had a unit test for the storage layer too.
Good Lord.
I wrote them. A slightly horrified feeling of how has nobody ever written tests for the storage layer of state in Synapse before.
Well, it's all PsyTest, right?
Yes.
Yeah. So there's some faff I need to do to actually hook it up, but theoretically it could just slot in today. So really the only reason I haven't done it is waiting for Rich to write the actual room version stuff.
Which should be coming fairly soon, I think, next week, and that gives us time to gather feedback on Eric's magnum opus. And so if you're interested in any of this stuff, go and check out MSC 1442 and go and stack it up and let us know what you think. I mean, there are many different ways of solving this, as we said. We've been pushing it, also throwing around ideas where you do synchronize the whole DAG all the way around the place and how you can do that efficiently, whether there's a way to do that with zero knowledge proofs of some way. Do you just do the state DAG, in which case I got obsessed with a variant of a full replication of the state DAG, but you ignore boring bits of it on the assumption that generally, if you're in a room where somebody just keeps changing the topic in a great big chunk, then you can just collapse that all down into one sort of semantically important thing. There are lots of different ways of skinning it, but this one has the advantage of being relatively incremental relative to what we have, and also working with the incremental algorithm that we had in the wings. So thank you, Eric, for the epic on getting this one out the door, and hopefully it will make the world a much better place in terms of fixing the security issues of ban evasions, as well as the horrifulness of state resets in the Hotel California bug, and also opening the door for us getting incremental state res out, so everything can go much, much faster, and then we should be in a much, much better place than we are today. Wow, that was a long one.
Yeah.
Thank you for guesting, Eric. Sorry for stealing you away from your unraveling of the week. And have a great weekend, everybody. And please upgrade to Synapse 33 now, if you haven't already.
Bye.